Dear children, today I would like to discuss low coordination numbers. Myself, Dr. Digna Varghese. Coordination number 1. Examples: the aryl radicals derived from the highly sterically hindered 135 triphenylphosphine forms 1-to-1 organometallic compounds of the type. Here you can see metal atom which is joined to 135 triphenylphosphine 1-1 position. Here the metal atom is directly joined to the carbon atom of the ligand. So it is an organometallic compound. Examples are CuC6H2C6H5 thrice and AgC6H2C6H5 thrice. Here metal may be copper or silver. Coordination number 2. Few complex ions are known with a coordination number 2. There are two geometric possibilities, linear and bent. If the two ligands are identical, that is, ligand-metal ligand, and their symmetries are D infinity H. If two ligands are arranged in a bent fashion, LML, its symmetry is C2V. The coordination number is restricted to some complexes of copper 1, silver 1, gold 1 and mercury 2. So they are limited to coinage metals and mercury 2 with +1 oxidation state of coinage metals and mercury with +2 oxidation state. Some examples are given here. AgCl2 minus CuNH3 twice 2 plus AgNH3 twice plus CuCl2 minus AgCl minus AuCl2 minus AgCN2 minus AuCN2 minus and HgCN2 minus. Dimethyl mercury Me2Hg. These are some examples of coordination number 2. Coordination number 2 usually found with coinage metals and mercury 2 ions. They are formed in solutions under ordinary laboratory conditions of the plus ions of coinage metals and group 1p metals. They are closely related to mercury 2 D10 species. Okay. Here you can see the gold 1 halides, that is AuCl2 minus, present good examples of linear 2 coordination. They consist of zigzag chains. Okay, its structure is like this, zigzag chains. Linear gold 1 complexes of formula of the type LAUX. In LAUX, where X is an halogen atom and L is a neutral, U is base. Examples for L is substituted phosphine R3P or thioether R2S. Two coordinate complexes often gain additional ligands to form 3 or 4 coordinate complexes. If we can see, this is a 2 coordinate complexes, but often it reacts with ligands, other ligands to form 3 or 4 coordinate complexes. Here you can see HgCN twice. It is a coordination number 2 complex that reacts with the 2 moles of cyanide ions and forming a 4 coordinate complex. Here you can see silver complex. Its coordination number is 2 that reacts with another 2 ammonia molecules and forming a coordination number 4 complex. So all the complexes can form higher coordination number complexes by gaining some additional ligands. We have seen that certain ligands added to the coordination number 2 complexes, it may be converted to higher coordination number complexes. So here we can see a formula of certain coordination compounds suggests a certain coordination number that might hide a polymeric chain with a higher coordination number. For example, copper cyanide appears to have coordination number 1, CuCN, in which copper is attached to one ligand only, so its coordination number is 1, but it in fact exists as linear CuCN chains, in which the coordination number of copper is 2. So we can see from the formula of certain coordination compounds, it suggests certain coordination number. It suggests only coordination number 1, but it exists as CuCN chains. So it's got in this compound, coordination number of copper is 2. Solids KCuCN twice possess a chain structure in which the coordination number of copper 1 is 3. Sterically hindered ligand is coordinated to metals such as manganese, iron 2+, cobalt 2+, and nickel 2+. The ligand is NSiMe3 twice minus NSiMePH2 twice minus NPHBMeS2 minus NPHBXY2 minus. Here, the boryl group draws off one of the lone pairs on nitrogen atom through nitrogen to boron dative bond. If bonding and reduces, the tendency of nitrogen to bridge can form dimeric complexes. Geometry of coordination number 2, that we know, linear and bend structure. If the n-1 d orbitals of the metal are sufficiently close in energy to ns and np orbitals, the dz² orbital can enter into the hybridization to remove electron density and the region of the ligands. The tendency for this to occur will be in the order mercury, which is equal to gold, that is greater than silver, which is greater than copper. Coordination number 3. This coordination number is rare among metal complexes. Examples for coordination number 3. A platinum complex PTPCy3 thrice, where Cy denotes cyclohexyl. MX3 compounds where X is a halogen are usually chains or networks with a higher coordination number and shared ligands. 3 coordinate complexes with 3 identical symmetric ligands normally have D3H symmetries. Here you can see the platinum PCy3. Cy is the cyclohexyl ring and which is attached to the phosphorus. Phosphorus is attached to the central metal atom. So its coordination number is 3. Here you can see some examples. CsCsCuCl3. It is found to be coordination number 3. But it is seen in infinite single chains of Cl, Cl, CuCl2, Cl. Its coordination number is 4, not 3. Here 2 chlorine atoms are at 228 picometer and 2 more chlorine atoms from the adjacent segments is found to be 278 picometer. This is due to the Jantler effect. Another one is KCuCl3. Here infinite double chains of Cl4, Cu2, Cl2, Cl4. Coordination number is found to be 6, distorted octahedron. Here you can see another examples, ammonium, cadmium chloride. Here infinite double chains forms and coordination number of cadmium is 6 here. It is undistorted. So these complexes are seems to be coordination number 3, but they are really not. Solid case CuCN twice possess a chain structure in which the coordination number of the copper one is 3. It seems to be coordination number 2, but it is not. It's really coordination number 3. Its structure is CnCuCn, CnCuCn, like this. It's a chain structure. Tris trimethyl phosphine sulfide copper 2 copper 1 perchlorate, that is CuSpMe3 thrice ClO4. Its structure you can see from this picture. Here you can see the copper atom, central metal atom, and the sulfur atom from the Sp trimethyl phosphine ligands. Sulfur is coordinated, 3 sulfur atom is coordinated to the central metal atom, so its coordination number is 3. Here you can see some other examples. Cyclotris chloro mu trimethyl phosphine sulfide copper 1. Its structure is, you can see, its coordination number is 3. Here each copper atom, that is joined to 2 sulfur atoms and 1 chlorine atoms here. So its coordination number is 3. We know for coordination number 3, the hybridization is sp2 hybridization, but some d orbital participation can be expected as in the case of linear hybrids, since a trigonal sp2 hybrid is also possible. Another one is tris tertiary butyl thiolate of mercury 2 ion. Here mercury is central metal atom that is joined to sulfur, 3 sulfur atoms from tertiary butyl thiolate. Another one is triiodomercurate 2 anion, that is Hgi3 minus. Tris triphenylphosphine platinum. These are some examples of coordination number 3 complexes. Geometry for coordination number 3. The geometry approximates an equilateral triangle with the metal atom at the center of the plane as expected for sp2 hybridization. A few examples are known in which the geometry is planar but not equilateral. Examples: T-shaped geometry. You can see from this structure of a copper complex. It is a T-shaped molecule. One angle may be 120 degree, maybe much greater than 120 degree, and it is a Y-shaped also. Here you can see a Y-shaped compound. Copper is attached to 2 nitrogen atoms and here 1 nitrogen atoms. One angle may be or much less than 120 degree. We know for sp2 hybridization the bond angle is 120 degree, but in the case of geometry for the coordination number 3, bond angle may be either greater than 120 degree or less than 120 degree. By this I conclude here. Thank you for your attention.